You're watching The Dish TV, the talk show from SRI International that highlights the most important part of our institute, our people. I'm Renita Malhotra Hora, Head of Marketing and Communications. Today I'm joined by Brian Foster, Associate Director at SRI Robotics. I asked him about RoboMiner, a robotics platform co-developed at SRI International to keep humans safe in hazardous mining environments.
We have a client who came to us looking for ways to get access to areas of a mine that they're not currently able to access. So originally they were thinking about both open pit mining and underground mining, but these are pretty hazardous environments. There's a lot of both dangers due to the environment created by the mining activity and dangers due to the geography of the area that the mines are in, so dangers from landslides or hillsides falling away. So they came to us looking for a solution to that, and the RoboMiner is a kind of collaborative design outcome that we came up with our customer that lets a miner do his job, but from the safety of a remote location. Our client is a company called NEX. They're based out of Chile, and they're a mining service provider and technology provider in the region. So we've been partnering with them for several years now to develop this technology. So we've gone from the laboratory here in SRI to actual field demonstrations and field uses of the system.
So how does this robot work?
So the robot works using one of our kind of core pieces of IP, which is our teleoperation code base. So this is very similar to some of our other robots we've built, the Taurus bomb disposal robot and other systems at a larger scale. So we have a roughly human-sized robot. It is on a mobile base, which has 4 wheels to navigate around the mining environment. And then it has a kind of human-sized torso, arms, and head. From the user's perspective, they see what the robot sees through a stereo vision display, so they can see in 3 dimensions. And they can use two controllers to move their arms, and the robot will mimic their motion. So they can look at the screen, see what the robot's seeing, and then reach out and grab and manipulate objects in the environment. In addition to that capability, we have other systems on the robot for situational awareness. We have 360-degree LiDAR, which lets us see other terrain hazards, obstacles, and equipment in the mining environment. We have GPS-based navigation, and we can use that in the future, at least, to integrate with some of the other teleoperated and autonomous equipment that's operating in the mine.
So why was it made to be roughly human size? I would have thought maybe something much smaller would be able to get into those areas better, no?
Sure, that makes sense. The mining environment is really well developed in terms of their existing processes. So one reason why a lot of our robots end up being roughly human size or having human capability is because that interfaces with the existing infrastructure and the existing environment. So this robot will initially be used for these hazardous areas where people can't get to, but it may also be used in some of the areas where people currently go, but allow these operators to not be exposed to the dust and the explosives and the other more managed hazards in the environment. So it's important that we have a system that can seamlessly integrate with the existing process and method of mining. So teaching a robot to work autonomously using machine learning or other artificial intelligence techniques can be very, very powerful. But it does have limitations, and some of those limitations really come to light in unpredictable environments. Because if the robot hasn't experienced something, it's very hard to have taught it how to handle that situation.
And what is the next stage, if you will, for this, either for this specific project? What would be the next stage in development?
So one of our tasks right now is to try and improve the speed that the RoboMiner can do its operations. We don't necessarily have to be as fast as a human because we can gain efficiencies other ways, like operating 24 hours a day, operating at night, other advantages we can take as a robotic system that humans aren't allowed to do.
And I wonder, has this specific robot been created with this particular environment in mind, which might be different from other mining environments?
Its capability is pretty broad. So in general, we'd categorize two kinds of mines that the robot is suitable for use in. And that would be an open pit mine and underground mine.
So what kinds of materials come out of an open pit mine versus an underground mine? And what is the difference in the function of the robot?
Yeah, if you take copper as an example, you can do copper mining from both below ground and from above ground. How you actually create that mine, what that mine looks like, is very, very different. So open pit mines, you may have seen pictures of these kind of terraced holes in the ground. That's an open pit mine. It works by clearing an area of ground, drilling holes in the rock, filling those holes with explosives, and pulverizing that layer of rock, then clearing that material out, doing that again. Versus an underground mine, which is probably what most people think of when they think of mines, which is a series of holes in the ground where you're drilling into the rock and pulling it out.
So, Brian, I can totally understand now why you said earlier that this is an example of research coming out of SRI that really works to our mission of making the world a safer, healthier, and more productive place. I'd love to ask you, how dangerous is mining? We know it's dangerous. We know it's very dangerous. But is there a way to quantify that and assess what difference this kind of robotics can actually make?
You know, I think there are two kind of categories of risk that you could look at from a human's perspective in the mines. One is the very, very specific and immediate risks. So in underground mines, the hazards are increased because of the confined environment, the dangers of collapses and other things that can happen down when you're down below all of this rock. But there are some, call them more environmental hazards, which are persistent and maybe not a huge risk day to day, but can accumulate over time. So one of those is dust. The result of the explosives in the mining environment is they're trying to pulverize the rock. And when they do that, they make a dust which is very, very fine, so very, very small particles. But it's not dust like you would experience in the normal world. It's never been weathered. It's never eroded. So it's very small, but very sharp. So this is really hazardous to inhale. And miners are supposed to wear respirators and other protective devices to prevent exposure to this dust. But it's something that they are exposed to day in and day out. So the long-term health impacts of that kind of environment can be pretty significant. And this system has the capability of removing that exposure risk completely from people.
Which makes me wonder then, could this kind of robot be applied to other use cases in dusty environments, construction perhaps, or something else similar, something maybe out in agriculture, which has maybe not dust in the same way, but debris or particles of some kind that would be hazardous?
Definitely. I mean, this system, the RoboMiner system, is a kind of applied research where we take some of our core capabilities and some existing commercial capabilities, and we put them together to address the specific need at hand. If we were to, say, go into agricultural environments or other factories or construction environments, we probably wouldn't use this system exactly as it is. But something perhaps that is similar to it, that uses some of the same core components in similar technologies.